Hello, friends. Welcome to Akulmach, and you're watching the science show. And we have brought a very interesting subject for you, which is regarding the gravitational wave. Now, knowledge of gravitational wave is widespread, but some of the people may be still catching up. So let me explain what are the gravitational waves. And gravitational waves are the biggest thing that universe has, because these are the waves which are created by the nature itself. It is these waves are created by very large objects whenever they interact. In fact, we are always being bathed in the waves which are creating in the gravity, in the area of gravity. Just like you have light waves, as lights is called light waves. Similarly, when the gravity travel, it also travels in the form of the waves. And this was actually first hypothesized by Einstein himself, none other than Einstein. Einstein said that because he gave the theory of relativity, and he said that, look, if anything has to travel, the fastest speed is the speed of light, which is also the speed of anything else in the universe. So if there is an impact of gravity which is going to happen, for example, if I am standing on Earth, then the effect of gravity on Earth is actually affecting me with the speed of light. So it's instantaneous. So whenever there is a gravity which is traveling out there in universe, it is actually traveling at the speed of light. So the gravity and the light has the same speed. Therefore, considering this phenomena, Einstein predicted that the gravity must also be traveling like a wave. And even though we do not understand too much about gravity itself, for instance, we do not know why gravity exists. Is there a particle? For example, if there is a light, we know that the light particle is photon. But is there a particle for gravity? So a lot of research is being done in that area, and we are trying to find out if there is a particle responsible for gravity. While this is going on, a few years back, scientists were able to convert the theory into reality. They were able to detect the gravitational wave. Now, the waves which were detected by the scientists on Earth originated because of the two black holes collided very, very far off, and their waves reached Earth. And the effect of the gravitational wave is that, since it is the gravity itself is traveling in the wave form, it will actually compress and elongate Earth along with the wave itself. And this is exactly what scientists are looking for, the effect of gravity on Earth. And therefore, even if such a event is proven, which is now proven because of these black holes, if we have a sensitive enough equipment, we could also get access to the gravitational wave coming from the Big Bang. And as you know, that Big Bang is the ultimate explosion, the biggest, largest explosion that you can expect in our universe. And that large, huge explosion would have created very, very huge gravitational waves long time ago. So if we have a sensitive enough equipment, we can measure the gravitational waves. These equipments are very specialized, as you can understand. Uh, Basically, to study the light, you need telescope, or interferometer, or things like that, which you can make. But to study gravity, which you cannot see, how can you make? So these kind of instruments are very, very sensitive, very specialized. So right now on Earth, there are two instruments. One is called LIGO, and other is called Virgo. And strategically, these LIGO and Virgo are located in opposite sides of the Earth, so that if there are two gravitational wave measuring instruments, then by using two setups, you can actually find out, you can triangulate and find out from which part of the universe these gravitational waves are coming. As you can see, let me explain very briefly the LIGO. Each tube on each side, which are at perpendicular to each other 90 degrees, they're intersecting at in this building. They are 2 kilometer 2 mile long, actually not 2 kilometer, 2 mile long. And at the other end there is a very sensitive, very extremely straight mirror which can bounce off a laser beam. And these instruments are so accurate, and they don't want any friction for laser beam to experience any friction. So these tubes are perfect vacuum. So you can imagine, building such a instrument is very time consuming. It requires a lot of accuracy, and also maintenance is quite expensive. So right now we are actually detecting gravitational waves coming from large collisions, large objects, like collision of Jupiter or collision of neutron stars, which will create very large gravitational imbalances, which we measure using LIGO and Virgo. Now, essentially what happens is, whenever we get a gravitational wave in these detectors, immediately all the telescopes in the on Earth also look in that direction from where the gravitational waves have come, and then the physical evidence in the form of light or X-ray is also measured. So this way we know exactly what is going on in that part of the universe, and therefore study of gravitational wave has become very, very essential to study the universe.
Well, very interesting, because this is a topic which I really adore, and I just always want to read more about gravitational forces and the impact of the gravitational forces. But Chandra, that all these kind of education, I think it should be given in the school level also, because nowadays we are entering modern era, and the new findings which are coming, it is very essential. I think the planners who are doing education planning, they should introduce the modern upbringing, and in they should include that kind of subjects in their studies, because that is quite a crucial subject. And to know about the gravitational force, the impact of gravitational force, and how it affects the day-to-day life, it's very essential to understand for the upcoming new generation. So, what do you think about this?
Absolutely, Kanchan. In fact, you have raised a very pertinent point. The gravity is a sort of assumed. We don't even think about gravity. We keep walking on the planet Earth. We keep firing our rockets, but we assume gravity. It is like a sort of a force which is omnipresent, and we don't consider this as a force itself. So it is important study. However, gravity is best explained by Einstein in the theory of relativity. Now, this is a very difficult subject for to speak, because Einstein himself said that person who understands relativity is the person who can explain to the other person. So it's very difficult subject, and it's not difficult from the scientific point of view. It is very difficult to imagine. So until and unless you know the relativity concepts, it is difficult for people to grapple the wave theory which is related to gravity, because as I said in the beginning, that we do not know how gravity function. Einstein said gravity is nothing, it's not a force, it's basically curvature of the space time. But then now we are learning that gravity is also traveling in the form of wave, just like wave travel on the surface of the water. So if we are floating in space, and if a wave passes through Earth, we will also move along with it. So we don't want to basically imagine that situation, because we think that we are very stable, we are standing on a stable ground. And if we come to know that no, the gravitational wave which has come to us, hit us from very far off, can make us shake even little bit, that is a very discomforting feeling. So I think we need to for any children to understand gravitational wave, they have to first study the theory of relativity and also nature of the universe. I think you have raised a very pertinent question, Kanchan, but I think a more deeper understanding of our space is required before you can start appreciating it. All right, so Thanks for asking, Kanchan, and let's move on. So I was telling you about these detectors. So right now, this subject itself is very new. We have two detectors, which is LIGO, LIGO, and Virgo, which is in Australia. LIGO is in US, and whenever there is the waves are detected, um, using the triangulation method, we can actually find out from where this wave has originated, and then immediately after that there is a proper coordination. All the telescopes present on earth or in lower earth orbit basically turn towards that location and find out or try to locate the physical evidence in the form of x-ray or light or some sort of explosion. So right now LIGO and Virgo are very specialized. They can measure the gravitational wave coming from very large object. But the theory is that the gravitational wave must be passing through us all the time. Even the microwaves, micro disturbance in the gravitational force field must be happening all the time. So, what is the way out? One method is that you can actually set up a similar apparatus out there, floating in some orbit, and that will make the things very expensive, and it will be very difficult to control because the accuracy required in LIGO and Virgo are very extreme, highly extreme, and vacuum and temperature control. All of that is quite technical, and because of these challenges, we have only two detectors. I mean, just compare the number of radio telescopes we have on Earth. There are thousands, but when it comes to gravitational wave, we have only two detectors on Earth. And even though India has agreed to set up a gravitational uh, detector to be set up in India under collaboration with United States, but that will take many years, few more years for a India-based gravity detector to come up. So it's a challenge. We ideally should be able to uh, get a more sensitive detector, and we should be able to detect all kinds of disturbances in the gravity force field. And that is why this latest study gives us a huge hope, and that is about the magnetosphere of the planets. And as you know that Earth has a very strong magnetosphere. In fact, the magnetosphere on Earth, which is a byproduct of the core, our core is not stable, it is rotating. Because of that, the huge amount of magnetism is produced, and this magnetism is responsible for the existence of life on Earth, because this magnetism actually protect us from harmful radiation coming from outer space or from sun. So we know that the Earth has a huge magnetosphere which extend beyond the atmosphere itself, many thousands of kilometers beyond the atmosphere. So the influence of planet Earth can be felt even outside to quite far off distances. So Earth has a huge magnetosphere, and there are living organisms on Earth which use this magnetic field to navigate on Earth, because every magnet has a north and south pole. So immediately, if you have a biological clock built into your mind, then you can actually navigate. So a lot of birds, fish, a lot of different animals, pigeons, they actually follow these magnetic lines which are available on Earth to do navigation. Uh, so the scientists started thinking that can we use this ready-made natural magnetosphere which is present on Earth to measure the uh, gravity. And that was a starting point of further research, because this is something which is natural, ready-made. We don't have to build the LIGO kind apparatus, which are very expensive to build, takes many years, requires a very high precision construction process and also maintenance. You needless to point out that you also need specialized people to manage these expensive facilities. So this is a new hypothesis. I think more research is required in terms of using the Earth magnetosphere to measure the gravitational wave. Now you may think, why magnetosphere? What is so crazy? Why magnetosphere will help us detect the gravity? Because magnetosphere is also part of the space time in which we are also present. So if the magnetism is being produced by a huge magnet, the gravity will also affect the same magnet as it will affect us. So I think to understand this further, we also need to understand that there are even bigger magnets present in our solar system, which is Jupiter, which is by far the strongest magnet after the sun. Jupiter produces highest amount of magnetism because sun is also producing huge amount of magnetism. The effect of sun's magnetism is felt far beyond the solar system, even outside the solar system, up to the extent of even the next star. So sun is definitely a very huge magnet, but when it comes to planets, Jupiter is another planet which is having very strong magnetism, much stronger than Earth. In fact, the Jupiter's magnet, it's so strong that it actually converts into a sort of radiation, and therefore Jupiter planet system is not safe for humans to visit, even though the planet is so beautiful. Nevertheless, we have the equipment to measure the magnetism or any changes which are happening on Jupiter with regard to magnetism, which we can measure from here. Also, we have a probe rotating around Jupiter, which is called Juno, which is also measuring these parameters of Jupiter. So we have a lot of satellites around Earth, and we also have a advanced enough satellite around Jupiter, which is rotating or in the orbit. So what happens, how this is an important study. I think it is very important to point out that whenever there is a gravitational wave passing through a strong magnetic field, it produces photons. And this is a new phenomena that we found, that the photons, the energy, the interaction between magnetism and the gravitational wave produces small amount of photons. And that is very exciting because now if the gravitational wave is passing through Earth magnetosphere, we have to basically focus our satellites to look at these small chunks of photon which are coming, and we have very sensitive photon detectors today because photons are nothing but light. So if there is a particular type of photon being generated because of the interaction between Earth magnetism as well as the gravitational waves which are passing through, the same wave will affect Jupiter as well. So if we detect using the natural magnet on Earth that such a photon being generated, we can immediately ask Juno to measure if the Juno is able to detect those photons in Jupiter. And now we have two detectors, natural detectors in our own solar system. We have the satellites which can measure the photons and which can tell us that the gravitational wave is affecting and generating these photons. And since there are two detectors in space in our own solar system, we will be able to triangulate and find out from where these waves are coming. So this is a much better way of detecting gravitational wave, and probably we will be able to also identify many kinds of gravitational wave, because right now LIGO and Virgo can detect only waves which are coming from huge objects like large collisions between black hole and neutron stars, but large planets like Jupiter or even stars, when they move in the space time, they must also be generating some gravitational wave, and these are all micro gravitational waves which our LIGO and Virgo are not able to detect.
So, Chandrakant, you have selected a very interesting subject, and by listening all these findings and what the space scientists are doing in the field of space, I really feel like joining ISRO. And every day I should encounter and learn the new things about the space, because now if you agree that space is the one field which is coming up for career also. So, and the subject is really very interesting, and I hope our audience will also find it very well done. All the best.
Thank you, Kanchan. I think this is a new field, and since gravitational wave study of gravitational wave is absolutely new, this is the right time for youngsters to pick up, because by the time they are ready to be employed, there will be a detector available in India. And also, if we are able to take this study forward, where we have a natural magnet like Earth and Jupiter, and we have the satellites already present around these planets, we can actually use these to measure the gravitational wave of all kinds. So this will open up a totally new kind of cosmology, which will help us understand many hidden objects in our space, because everything in space generates some amount of gravity, and if we can actually measure the effect of that from far off, then it will tell us more about our near objects or even far off objects. So this is very exciting. And as I said that in our solar system we have two strong magnets. In fact, Mercury is also a very strong magnet, but I think two are sufficient, because Earth is quite strong. Earth has one of the strongest magnetism available, and Jupiter is the strongest magnetic effect, or a planet generating magnet after the sun. So if we have two locations within our solar system, we can combine the two and actually use the natural properties of these natural large magnets to detect the gravitational waves. uh, I think this is not a conclusive research is going on, because I think in order to detect these photons which are of a special frequency, or we have to understand what kind of waves are able to generate these photons whenever the gravitational wave hits these large magnets. I think a lot of research is being done, a lot of experiments are being done. This is not conclusive. So as and when more information is available on the subject, I will do digging for you, do research, and come back to you with more details. So friends, if you have any question, please do not hesitate to write back. And thanks for watching. As always, I will see you in the next session. Until then, have a nice day. Bye bye for today.